The Claude Stack, 5 layers, from raw tokens to autonomous agents. Here it is, top to bottom: surfaces, orchestration, reach, protocol, and the model. 5 layers. We'll build them one at a time. Think of the 5-layer internet model: physical, link, internet, transport, application. Each layer hides the one below. You send a text without ever thinking about voltages on a wire. Important, this is a teaching analogy. The Claude Stack is not a network protocol. The idea of layers carries over, not the specific semantics of OSI. And it lines up one for one. Physical, the raw signal on the wire, is L0, the model, turning tokens into tokens. Link, a single framed hop, is L1, the messages API, one call, one stop reason. Internet, routing out to other hosts, is L2, reach, tools and MCP touching the world. Transport, a reliable ongoing connection, is L3, orchestration, the agent loop holding a session together. And application, what the user opens, is L4, the surfaces, Claude Code, the SDK, managed agents. At the bottom, the model, 3 tiers. Haiku is fast and cheap. Sonnet is the balanced default. Opus is the heavyweight. They turn tokens into tokens. That is all they do. You don't talk to the model directly. You make one HTTP call to the messages API. It answers with a stop reason, the field that tells you whether the model is done, wants a tool, or hit a limit. Hold that word. Half of L3 is built on it. A model can't read your database or hit an API. It can only describe what it wants. That's a tool call. Tools and MCP, the model context protocol, are how that description becomes a real action. Now stack these. Call the model. It returns a stop reason saying it wants a tool. You run the tool. You call the model again with the result. You loop. That loop is an agent. Hooks fire at lifecycle points. Subagents get their own context. Memory persists. At the top, the things you actually open and install. Claude Code is the terminal agent. The Agent SDK, formerly the Claude Code SDK, is the library version. Managed agents are Anthropic hosted. They're all the layers below, packaged. 2 planes cut through every layer, like security and quality of service in a network. Prompts shape how the model interprets everything above L0. Cost and reliability show up as tokens, caching, tool latency, loop length, and deployment surfaces. Each layer trusts the one below and serves the one above. Start at L0, just text in, text out. L1 wraps the model in a single call and returns stop reason. Without that field, the agent loop has nothing to read. L2 only makes sense once you accept L0. The model just produces text describing a tool. MCP is the contract that turns that text into action. L3 is the loop. You can't understand agents without stop reason from L1 and tools from L2. L4 is packaging. Claude Code, the Agent SDK, managed agents, all of them are the 4 lower layers dressed for a use case. Here's the detail almost no Claude explainer covers. Stop reason is not a status code. It's the field the agent loop reads to decide what to do next. End turn means stop. Tool use means run the tool and call back. Max tokens means you hit a limit. Stop sequence means a custom stop matched. Half of L3 is just reading this value in a loop. We'll come back to it in episode 1. Try it, MCP, that's L2, the agent's reach into the world. Hooks, that's L3, lifecycle of the agent loop. Prompt caching, that's the cost plane. It cuts across every layer. You now have a place to put every new feature Anthropic ships. Next layer up? No, next we go down to L0, the model itself. The Claude Stack. Grab the cheat sheet linked below.